Today we are now going to do a deriving formulas 6, the cubic formula. Now you may know why I have been on a hiatus for a day now. It's because that day, which was yesterday, was the MAT exam day. But now we're going to do something different. Since we're all on the MATs now and just cleared our brains, why don't we just warm you up with another formula which is much more interesting than the quadratic formula, which might be the most complicated formula you learned. Today, we are now going to learn how to solve a cubic. Silence? Enough? Well, that's great because we're now going to progress on the algebra. So let's assume the cubic is of this form and there's an a at the front. We can just as easily take it out by dividing all the terms by the coefficient. So the x squared, why are we taking out the x squared? Is because we're going to make it easier to see. So y equals to x minus b over 3, and then we get a cubic on the form y cubed plus py plus q equals to 0. Because if you do the expansion, the next term will be x cubed minus bx, etc., etc., etc. So you get y cubed plus py plus q equals to 0. You can figure out these algebraic expressions yourself. Right now, we are now going to solve this cubic. Let's do a binomial theorem. U plus v cubed is u cubed plus 3u squared v plus 3uv squared plus v cubed. Now you realize why am I using Microsoft Word here? It has equations. So u plus v cubed equals to u cubed plus 3uv u plus v cubed. Now you may be thinking, why are we doing this? It is so that we can convert it into a y cubed plus py plus q equals to 0 equation. And then we get this. U plus v cubed minus 3uv u plus v minus u cubed plus v cubed equals to 0. Then, now here's the genius bit. P equals to 3uv and q equals to u cubed plus v cubed. The reason why I highlight this equation blue is that we're going to see something magic happen. So p cubed is 27u cubed v cubed and p cubed over 27 is u cubed v cubed. Again, I highlighted this equation blue because this is completely magic. And we're now going to use some Vieta's formulae. So ax squared of bx plus c equals to 0. The sum of the roots is negative b over a, and the product of the roots is c over a. When the first term is 1, that's even easier, because then the sum of the roots is the second coefficient, negative, and the product of the root is the third coefficient. So we can use this principle to derive a quadratic where u is the solution. See, if u and v are the two solutions of the quadratic and x is u plus v, then x is the sum of the two roots on this quadratic. The rest you can do, you can solve this and look, it's just the same quadratic written again. I don't know why I did this. So u, using the quadratic formula, is q over 2 plus minus root q squared over 4 minus p cubed over 7. So why is this? So this u is supposed to be I name it u, but it's supposed to be u cubed or v cubed in this equation. So y is this. Then, and what if you want all three solutions? Well, you can just copy paste the cubic formula and tuck some numbers on the end. Want to know why? Because we are now going to use complex numbers. Complex numbers are very, very handy too. So omega equals to e to the power of 2 pi I over 3. So this basically means it's a complex number that's a third of a rotation anti-clockwise from 1. So this will be negative half plus square root of 3 over 2i if you're doing complex solutions. The reason why I didn't put omega here and omega squared here is because it would be pretty pointless for a cubic to have all three roots a scalar multiple on each other, because that's not what a normal cubic does, right? Well, I guess see you again!